Today, I am going to show you how you can DIY an entire home theater audio setup. Well, except for the subwoofer, and I'll explain why later. To start our journey, we are going to build these tower speakers. These are the TMM Overnight Sensations originally designed by Paul Carmody. If you're building a sound system from the ground up, these are the speakers that I would start with. As your front and left channels, they are going to be the ones that you use the most often. And also, these are probably the most technically correct speakers that I've built to date. I took all the lessons I learned while building my other speakers and applied them to these. In fact, I actually built those towers in order to replace these hardwood speakers that I currently use as my rear channels. So once we're done, I'll have a comparison where you can hear the difference that a larger and more technically correct speaker has on sound quality. So with all that being said, let's get started on the build. Today, we are going to be building our speaker cabinets out of MDF. Now, MDF is actually the optimal material to use for speaker cabinets because of its uniform density. However, it looks like this, so it's gonna present some interesting finishing challenges for us. But we'll talk about that once we get to it. For now, let's just cut this guy up and assemble it into a box. The problem with using hardwood to make speaker cabinets is that because it's a natural material, different parts of the wood are going to have different densities. And that can introduce distortion, as one area of the cabinet will reflect sound differently than another area of the cabinet. MDF, on the other hand, doesn't have that problem. So it should make for at least a slightly better sounding final speaker. Since these are tower speakers, I started by ripping some long, narrow pieces and then cut them to length on the miter saw. You can see here that I set up a little stop block to make sure that all of my pieces ended up being the exact same length, which should make my assembly later on a lot easier. Now that we got all these pieces cut, we are almost ready to start assembly, but before we do that, we have to make some window braces. And if you didn't know, a window brace is basically just a structural element that adds strength and rigidity to the speaker's cabinet while still allowing air to move around freely inside of it, which is important for a tower speaker because one of their main advantages is that massive internal air volume. Having a lot of free air floating around inside the cabinets means that the drivers are able to more easily and efficiently do their job of moving air in front of the cabinet, aka generating sound waves. Compared to my older, smaller speakers, these new ones should have a lot more low and mid-range oomph while still being able to deliver crisp highs. And that's all thanks to that more efficient design. Assembly was a bit messy with a lot of glue, but it's better to overdo it here as you're trying to create a completely sealed chamber. And besides, any excess glue can easily just be wiped off. There's one speaker cabinet done, and then 2 speaker cabinets done. Or at least we're done with the back half of the cabinets. We still have to do the fronts. And here's the thing, I don't want to make some boring rectangular speakers. So I think we need to find a way to spice up the design of these front baffles a little bit. We just need to find some inspiration here in the shop. Maybe. Now we're talking. That's it, we're gonna use the power of plagiarism to design these front baffles. Give me a couple seconds to whip something up on the CNC control software, and then we are gonna cut these guys on my X-Carve. 20 minutes was all it took to whip up a quick design, and the machine got to work cutting out some fresh faceplates while I busied myself with a couple of other jobs. Well, the X-Carve is over there doing its thing. We're gonna, you know what, this is dumb me yelling. I'll just tell you guys in a voiceover. On the back side of each cabinet, I needed 2 2-inch cutouts. The first one, up top, is a specially designed breather port that allows air to move in and out of the cabinets as necessary. The length of it is pretty important, so make sure you check your speaker specs before installing it. Down below that is a hole to mount an input plate where I'll eventually connect the speakers to my AV receiver. Now, I put the breather port up higher so that it would be less likely to be blocked by baseboards, cat toys, and stuff like that. Next, I set up to install the front of each speaker tower. Originally, I was going to install all of the speaker components first and then seal up the boxes, but that would have actually been a big mistake, and I'll explain why later when we're installing the front plates. With the X-Carve nearing completion, I really had to pick up the pace. With the glue barely dry, I started cutting out large openings on the front of both cabinets. And good dust extraction, as well as proper PPE, is important here as MDF dust is really nasty. All right, the carve is done, just about the same time as me finishing the modifications to the box. However, I gotta give a slight edge to the machine. It did beat me by a few minutes. These are going to sit on front of the speaker cases, something like that. So obviously these guys are still a little rough around the edges from the initial carve. So why don't we clean them up, get them painted, and get them ready to be installed. After punching the centers out and sanding off what was left of the tabs, I set up over on the router table and gave all of the exterior edges a good healthy round over. One of the reasons, aside from aesthetics, that I wanted to add these front plates to my speakers is because they should help with sound quality. On my old speakers, I recessed the drivers from the front face of the cabinets, which theoretically adds a bit of interference to the sound waves as they're coming off of the drivers. On these new speakers, the drivers will sit perfectly flush with the front face of the cabinets, so there's nothing in the way to introduce any distortion. We're gonna leave these guys to dry for the next little bit. While they do, we're gonna get started on the electronic components that go inside these speakers. This is a crossover. And what it is a relatively simple circuit that sits inside of your speakers and separates out the different audio frequencies and sends them to the correct drivers. It looks complicated, but I'm gonna let you in on a little secret. You don't have to be an electrical engineering genius to figure out how to wire up your own crossover. In fact, I don't even know what half of the components on this board do. However, I am able to follow very simple and very clear instructions like the ones that I got when I purchased all of these parts for the crossover as a kit. So the only real skill you need in order to assemble your own crossover is the ability to follow instructions and to work a soldering iron. And honestly, you don't even have to be that good with a soldering iron. I know I'm not. In order to give myself some landmarks to work off of, I started by screwing my terminals in place, which can be a bit tricky at times. These are junction points where you will connect all of your various components. Then I moved on to placing the capacitors, inductors, and resistors. There's a ton of different ways to mount these, but I prefer CA glue because it sets instantly when you hit it with a catalyzing spray. So if you want to get some for yourself, I'll include a link down in the video description. Now that we have all of the components roughly where they need to be and twisted together, it's time to do the actual soldering. And check it out, I went and got myself a little soldering station kit as a treat for myself to make this project go a little bit faster. When you first start soldering, your crossover is gonna look like a giant bowl of spaghetti with wires going in all sorts of different directions. But just stay calm, stick to the instructions, and work one component at a time. Before you know it, you'll have a clean, organized circuit that's ready to be installed. Oh, and as a little bonus step, I installed these solderless connectors to the ends of each wire that runs from the crossover back to the drivers. This isn't strictly necessary, but it will make installation and any potential troubleshooting a lot easier. Now, I think we need to address how we're gonna finish these cabinets. Obviously, I wasn't just gonna leave these cabinets as bare MDF. I don't think that would look very good. So today, we're gonna do something that I have never done before, and I'm quite excited to try it out, but also kind of nervous. We are going to... That was significantly less slick than I thought it would be. Today, we are going to veneer these cabinets with some real wood veneer. So, I think the first thing we need to do is cut down this big giant sheet into some more manageable sized pieces. When it comes to pre-cutting veneer like this, don't get too fancy and cut it so that it's the perfect size to cover the face of your cabinets. Make it an inch or so too big, and that way you'll have some room for error later when you go to install it. Trust me, it'll be a lot easier. Now that I got all these pieces cut, it's time to start attaching them to the cabinets. And in order to explain that step, I think I'm actually gonna switch to voiceover because it's about to get real stinky in here. That's because I opted to install my veneer using contact cement. After a bit of research online, this seemed like it would provide the best hold, but the downside is that it's quite stinky and quite toxic. Oh, and also the installation process is really weird. Let me explain. First, as you can see, you roll it onto both of the surfaces that you want to stick together. Try to distribute it as evenly as possible, but don't work it for too long because it starts to set up really quickly, which is good because it does need to dry fully before you can adhere it. I told you, it's a bit weird. Once everything is dry to the touch, you can finally start bonding. I use these wood dowels as spacers to help with alignment, and then once I had the veneer where I wanted it, I removed them one at a time. A little bit of light pressure is all it should take to permanently bond the two surfaces together. But if you want to be extra safe, a big glue roller like this one should make sure that you don't miss anything. It was definitely a bit odd to have two seemingly dry surfaces bond together so well, but I guess that's just the magic of science. Before you move on and start veneering your next surface, it's probably a good idea to trim the excess off of the surface you just did. Some people will use a trim router for this step, but I found a sharp knife did the job just fine, and a little bit of 220 sandpaper smoothed over that freshly cut edge. I made a pretty good mess while installing my first few sheets of veneer, but by the time I got around to doing the 10th, 11th, and 12th faces of the cabinet, I was starting to get a good feel for it. If possible, I would highly recommend you do a few practice applications before jumping into any mission critical work. Well, that was challenging to say the least, but hey, I learned a new skill today and I think these look pretty decent overall. I mean, obviously it doesn't look as good as a full hardwood would, but you know, from 2-3 feet away, it's really hard to tell that this isn't real wood. So now the next thing we need to do is cut out all of the holes where all the components are gonna go. So let's do that with a drill and a trim router. The drill will give you an initial entry point, and then a good sharp flush trim bit will trim the veneer flush to all the holes that you cut earlier. This part was actually really satisfying. Now, one of the nice things about working with veneer is that it's basically pre-sanded and ready to go as soon as you apply it. However, I am gonna do a little bit of sanding. And the reason for that is, well, just because I've been kind of rough with these while I've been moving them around, so I've got some little scratch marks on them. There's also a couple spots where the glue dripped over the edge when I was veneering other sides, and I just wanna polish off that glue and make these look nice. But I am not going to do the full sand where I start with 80 grit. I'm gonna go right to 240, because this veneer is really thin and I don't want to burn through it accidentally. When you're working with material that's this thin, it's really important that you keep the sander flat and don't hold it in the same position for very long. If you try to round over an edge or something like that, you'll burn right through the veneer before you even realize it. So just be careful. Now, as much as I would love to continue on my theme of trying new things by trying out a new finish, unfortunately, I really want these speakers to match my existing speakers, so I'm gonna finish them with the exact same finish that I did those other speakers. It's water-based polyurethane. Roll it on, give it a sand, roll on another coat. It's gonna be a little bit boring, so honestly, we're not gonna spend much time on this. All right, that is it for finish. So I'm gonna let these guys dry, and we'll start assembling them. First, we'll do the easiest bit, these breather ports. They just tapped right into place. Next, I did the input plates, which were slightly harder, but not really. And then it was time to mount the crossovers. I carefully lowered them into position, screwed them to the back of the cabinet, and then connected all of my wires. And now, before we go any further, I want to take a quick second and stuff these cabinets full of this stuff, which is Dacron. And the point of Dacron is to absorb and dampen any renegade sound waves that might be bouncing around inside your cabinet and muddying sound quality. In the past, I've used polyfill for this step, which is the filling that you would find in a cheap dollar store pillow. Honestly, I'm pretty sure it's the same stuff, but this has a fancy brand name attached to it, so it obviously performs way better. Wish I had made these windows inside here a little bit bigger. I keep scraping my elbows. Now we're ready to install the faceplates. Now at this point, you're probably thinking that I shouldn't be permanently installing these faceplates. What if I want to get in there at some point in the future and service these speakers? Well, earlier when I was making my crossover, I carefully sized it so that it can fit through either of the driver openings, which is a principle that you should always be applying when you're making speakers. This way, if I ever need to get in there for any reason, all I have to do is unscrew one of the drivers. Paint is now dry, and we are ready to finally install our drivers. We got ourselves a little bit of an issue here. You see, I bought these cool little hex head screws, and in preparation for that, I bought some hex head impact Allen key bits. What am I saying here? Anyways, I can't find them anywhere in the shop, so I'm gonna teach you guys a little trick. We're gonna modify this Allen key to be a bit that you can put in a drill. First, you're going to want to clamp it securely in place, and then hack off the last 2 inches or so using a bandsaw or something similar. Take that little bit that I just cut out and put it in the front of your drill. Well, something like that. Oh, and before I forget, each one of these speaker drivers comes with a little self-adhesive sound dampening ring that goes inside the cutout for it. At this point, you're probably starting to notice a little bit of a trend here. Good sound quality is all about isolating the drivers. You want to hear the sound waves that they're making, not the drivers rattling around inside their own cutouts. Next, it was finally time to start installing the drivers. Because I attached those little solderless connectors to the ends of each wire, this was really easy. All I had to do was clip them to the contacts and then drop them in place. Then, using my newly created Allen bit, I was able to quickly and easily screw them in place. Just be careful you don't over crank them, as the metal flanges are quite thin. Ooh, Does that not look nice or what? So at this point, we're basically done. However, I would like to do one last little bonus step before taking these guys home. I decided to add 4 leveler legs to the bottom of each speaker. Not only will these keep my tall tower speakers from tipping over on uneven floors and potentially injuring someone, but they also have these felt pads on the bottom of them, which should help to dampen the speakers by isolating them from the floor and providing yet another very, very slight increase to sound quality. There we go. With that last little piece in place, we are done. So let's take these speakers home and finally answer that question of, are bigger, properly made speakers better sounding than what I made before? Oh man, these are heavy. Oh my God, why did I make them so heavy? So I think the headline is they sound great. Compared to these smaller speakers, they have much better low and mid-range clarity, which is great for listening to music, but the area that I found where it's made the biggest difference is listening to dialogue in TV shows and movies. It's just so much easier to understand people talking. It's interesting too, because I've never felt like I was lacking bass before. This big subwoofer here behind me kind of has that end covered, but I think where I was really lacking was in that lower part of the mid-range, if that makes any sense. So yeah, big speakers are definitely better, and I'm glad I upgraded. So now let's talk about all those things I did, like using MDF instead of hardwood and using Dacron instead of polyfill. I can't rightfully say whether or not those things made a big difference because I don't have a good point of comparison, but I will say this. One of the things that I've learned from making my own speakers is that you don't really know what good speakers sound like until you get a set, bring them home and start listening to them. And then after a few days, they just kind of sound normal to you. You essentially just raise the bar for what your own level of acceptable audio quality is. Now, I know that might sound a little bit discouraging at first, but hear me out on this one. If you take the time to build a set of speakers that you're really proud of, you're always going to enjoy them. Probably not for their technical accuracy, but you'll remember all the things you learned while making them. And whenever somebody comes over to your house, you'll be able to say, yeah, I made those. In this section of the video, we are going to break all of the rules and build a severely underrated part of any home theater, the center channel. Now, a lot of the mistakes I made in this project actually ended up informing the decisions I made when it came time to build the tower speakers. If there's one thing I've learned, it's that every building project has its pain points, but those pain points are what then push you to do better in the next iteration. So that is exactly why I had these building is pain and pain is building t-shirts made. I just like being able to look down at this anytime I'm struggling with a project and think, yeah, this might suck right now, but it's making me a better builder in the long run. So if you want to get one for yourself, I'll include some links down below the video. For reference, I'm 6'1", about $180, and I am currently wearing a large. All right, now that we got that out of the way, let's get into this next project. Here in front of me, we have all of the stuff we're gonna need to build these speakers. We have the wood for the cabinets and then the various components that actually go inside the speaker itself. We're gonna set this stuff aside for the time being and focus on the woodworking and start by building the box for these speakers. In keeping with my previous design, my woods of choice for this build were walnut and ash. The walnut I cut into 2-inch and 4-inch strips, and the ash I cut into narrow little 1-inch wide pieces for the accent strip. You might also notice that I've made a new addition to my table saw. That's a magnetic featherboard, and if you've never seen a featherboard before, think of it like a helpful friend who isn't afraid to get their fingers within an inch of the saw blade to help you get the perfect cut. What you see in front of me here are the 2 halves of our speaker cabinet, or they will be as soon as we glue them together. Now, many people don't realize this, but the internal volume of a speaker cabinet is actually an important part of its design. So I had to make sure these glued up boards were big enough for the job at hand. Thankfully, I was working to the specs of a kit, so I didn't have to do too many complex calculations. However, I was going off the beaten path a little bit here. The instructions included with my kit only gave me the exterior dimensions of the cabinet and assumed it would be built out of 1/2-inch MDF. Seeing as I was actually making it out of 3/4 thick hardwood, I had to make a few allowances. Remember, like so many other things in life, when it comes to building speakers, it's the internal volume that counts. Wait, that's the expression, right? while we wait for these to dry, why don't we cut the front and back panels out of the sheet of MDF? MDF is the ideal material to make a set of speaker cabinets out of, but I don't know, I really like the look of a real hardwood, so I'm willing to take the sound quality hit in order to get that look. But the front and back panels I'm gonna paint, so why not make them out of MDF? As I talked about in the last project, MDF's uniform density makes it ideal for sound quality. But one of the best parts about building your own speakers is that you get to pick and choose when you prioritize form over function. And honestly, we're talking about a theoretical difference here that's probably not going to be detectable by like 99% of people, so try not to stress out too much about it. All right, these guys look dry now, so let's take off these clamps and clean them up on the drum sander. With the clamps off, it was time to do my usual cleanup and leveling over on the drum sander. I've shown how useful my drum sander is in the past for doing large tabletops and stuff like that, but I think it really shines when it comes to sanding multiple smaller components. Provided they're all the same thickness, there's no reason you can't run a bunch through in parallel like I did here. Back over on the table saw, I carried a second design theme over from my original speakers, that front chamfer. Again, this is one of those things that technically hurts sound quality. For the best possible sound, you want the sound waves to come off the drivers and not be interrupted by any extrusions. Just like the MDF versus hardwood comparison though, the degree to which this actually matters is probably lost on my uninformed ears, but at least now you know if you have better ears than I do and you want to build the best speakers possible. The next thing I did was cut some 1/2-inch dados for my 2 MDF panels. This would have been faster and easier with a proper dado stack, but on my table saw, switching to a dado stack also requires switching to a different brake, which I didn't happen to have at the moment, so I took the scenic route and cut my dados one blade width at a time. After a quick test fit of the front panel, I switched over and started cutting one for the rear. My friend the featherboard was also massively helpful here too. It kept the wood perfectly aligned with the blade the whole way through the cut, which ensured my dados had a uniform width. So, believe it or not, these two pieces here are going to form the entire exterior of our cabinet. This is gonna be the top piece, this is gonna be the left piece, this is gonna be the bottom, and this is gonna be the right. Obviously, we have 2 pieces here, so we're gonna need to cut them into 4 using the miter saw. When it came to cutting these miters, I had 2 main challenges. The first of which was getting perfect 45-degree cuts. Based on my own personal experience, most miter saws are not well calibrated from the factory and can be out by as much as a full degree, which doesn't sound like much, but when you compound that error across 8 cuts, it can end up making a big difference. So before you start cutting, check your saw against a known good reference. The other thing I had to watch out for was keeping my mirrored pieces the exact same length. And just like in my last project, I achieved this with a really cheap and easy solution: stop blocks. Just clamp them in place and butt your wood to them before cutting. All right, so let's do a little test assembly here. Get this slotted in. Guy goes here. Come on, there we go. So at this point, I think you guys can kind of understand how this is gonna go together. So the next thing we have to do is cut the openings for the drivers in this front panel here. Believe it or not, the location of and the distance between drivers is also an important factor in sound quality. Started to get overwhelmed by all the things that can affect sound quality? Yeah, me too. At this point, I felt like I had made enough intentional sacrifices in that department, so I laid out all 5 drivers just like the instructions told me to. That's right, 5 drivers. 4 3-inch woofers for the midtones, and 1 1-inch tweeter for the high-pitched sounds. I cut the 3-inch holes first with a sacrificial piece of MDF underneath the front panel to make sure I didn't get any backside blowout. Sitting here watching this footage is a great reminder that I need to get some sharper hole saws. It's tough to tell if they were cutting through the MDF or just friction burning their way through. Once that was done, I switched over to an equally dull 1-inch hole saw and cut the tweeter hole. After that, it was back over to the assembly table for a little bit of painting. We are almost ready to start assembling the speaker cabinet, but I think I'm going to paint these panels before I assemble it, because it's always easier to paint stuff before you assemble it. The paint I'm using here is an ultra flat dark gray, which matches the other speakers in my setup. I chose to roll it on because I prefer the texture you get from a roller versus a brush, but that's really a personal preference thing, and as far as I know, it doesn't have any impact on sound quality. I rolled 2 coats on the front, 1 on the back, and then left it to dry. This is feeling pretty dry, so I think we are ready to start assembling. The hardest part about assembling this cabinet was keeping all 6 of its pieces aligned and in place. Thankfully, I have a little trick to help with that. I like to tape the corners of boxes while assembling them. This keeps everything where it's supposed to be, but still allows you enough flexibility to fold the pieces up and into position. With my tape hinges in place, it was just a matter of applying a little bit of glue to all the seams and then slowly and carefully folding the cabinet into its final shape. Clamping the whole thing together was a bit tricky, but if you've seen any of my other videos, you know that I'm not scared of a little clamp challenge. This actually would have been a great time to use one of those strappy picture framey clamp things. Unfortunately, I don't own one of those, but I still managed to get it done with my regular clamps. The actual cabinet itself is looking great. I got all the clamps off it. We still have to do a little bit of a touch up. We had to sand and apply the actual finish to it, but other than that, it's largely done. One thing we do have to do is cut a hole in the back of it here, a little access hatch, so that we can do all the wiring of the internal components and mount this plate. If you don't have an oscillating multi-tool in your toolkit, pause this video right now and go order one. Seriously, these things are so handy, especially the cordless ones. Without mine, it would have been really annoying to cut this access hole after the fact. Oh, and don't worry, the panel that goes over this hole is slightly larger than the opening, so I didn't have to worry about making my cuts particularly clean. Okay, got that cut. Let's do a quick test fit. And yeah, that is pretty perfect. And they're nice, doesn't vibrate. All right, let's move on to some finishing. As you might expect with a build this small, the finishing was pretty quick and painless, so I'll breeze through this part. I sanded the whole cabinet to 220 grit, gently rounded off all of the hard corners, and then brushed on a few coats of my favorite hybrid polyurethane. Normally I'd roll my finish on, but since there were so many tight interior corners, I opted for a brush instead. If I were to do this build again though, I might actually apply 1 or 2 coats to the cabinet pre-assembly and then do a final touch-up coat after to avoid all this cutting. Let's let that dry, and while it's drying, we'll get started on the internals of this speaker. In front of me here, I have all of the various internal components of the speaker system, or I guess in the case of the drivers, I also have some of the external components as well. So this is the panel that gets mounted to the back of the speaker, and on it, we are going to mount and wire up a crossover. Prior to actually soldering everything together, I did a quick dry run to figure out the spacing and location of all the various components. Once I was confident I knew where everything went, I started permanently mounting things in place. I screwed down these terminals, but for basically everything else, I just used CA glue. A couple of drops and then a quick hit of the catalyzing spray is all it takes. Some people use hot glue, and I think there's even actually some specialty glues made specifically for speaker components, but it's hard to beat the convenience of CA glue. From there, it was just a matter of twisting together the various component leads, soldering them together, and then trimming off any excess. When it comes to soldering, you should try to avoid getting a bunch of solder on your iron and then just kind of smearing it all over the wires. It might work for a bit, but this can lead to poor connectivity and decreased sound quality. For the best possible connection, use your iron to heat up the knots of wires and then melt your solder into them. Okay, so I think that's our crossover all wired up and ready to go. So now let's move on to wiring up the actual drivers. This should be pretty straightforward, just cut wires, strip the wire, and then crimp them onto these little connectors. Don't have a proper pair of crimpers, but these pliers seem to be getting the job done. Cool. Connect this onto here, and then this end of it connects onto the speaker like so. So pretty simple. You just have to do that like 4, 5, 6 more times. I don't really know. We're gonna have to do it quite a few times. It wasn't that bad. A few minutes of stripping and crimping later, and I had all the drivers hooked up. This crazy bowl of spaghetti you see in front of me here should now be a 100% functional speaker system. Unfortunately, I forgot to bring an amp with me today so that I could test this before assembling it, but thankfully all these little quick release connectors should make it relatively easy to troubleshoot the setup if I did anything wrong. We're almost ready to start installing all of this stuff in the cabinet, but we have a couple more jobs to do before we can do that. The first thing was just reinforcing all of my crimps with a little bit of solder. This just made sure that those wires were firmly attached to the connectors because honestly, I didn't really trust my crimping job. The second thing I had to do was remove a little bit of material from each of these holes. I cut them tight to the diameter of the driver, but as you can see here, when you attach the wires, they stick out a little bit. So these notches are just to accommodate that extra mass. Also, quick side note, you can see I'm using a drill here, but really a Dremel or a die grinder would have made this job a lot easier. I think we're finally ready to start assembling. We got all our prep work done. First thing we're gonna do is the 2 outer pairs. This is a great example of do as I say and not as I do. Always, always, always test your electronic components before assembly. I was flying completely blind here and had no way of knowing if this speaker would work once I plugged it in. And yet, I did it anyways. So basically what I'm doing here is recreating that twisted bowl of spaghetti from the workbench, except now I'm doing it inside the speaker cabinet. I'd connect the wire to the driver, thread it through the box, and connect it back to the crossover. Once I was satisfied that my leads were connected and in the right place, I weaved in some sound dampening material and did my best not to knock off any of those leads that I had just worked so hard to place. I'm pretty sure this is the same stuff you'd find inside of a cheap pillow, and what it's supposed to do is absorb and dampen any sound waves bouncing around inside the speaker. You don't want those dirty secondhand sound waves, you want the crisp, fresh ones coming directly off the driver. Finally, it was time to start screwing everything in place, and I can't believe I made it this far without talking about these 3-inch drivers. They're basically the entire reason I chose the Overnight Sensation kit. Once I saw that cool metallic bronzy color on them and imagined how it would look paired with a nice walnut, I was sold. These ones specifically are called the B3Ns by Hi-Fi, who also happens to make the tweeter I used here, the T20, but that doesn't have a metallic front, so it's hard to get nearly as excited about it. Also, check out these cool hex cap screws that came with the kit. At first I was a bit bummed because this meant I would have to screw them in manually, but in retrospect I really dig the industrial vibe they create. And with those last few screws in place, we are now done, or at least I hope we're done. So because I didn't bring some sort of amp or driver to drive this thing with, I don't really know whether or not everything's working in there. So we got to take this thing home and hook it up to the sound system at home to know whether or not we're done. So let's go do that. I should have clarified this earlier, but this is considered a passive speaker, which means that it needs to be plugged into an amp, or in my case, I have an AV receiver underneath my TV in order to power it and make sound come out of it. So we're gonna hook this thing up and pray to the electronics gods that I did all the wiring right. This should be as easy as just threading this wire in here, this one in here, threading them both back through this conveniently located hole, and then connecting them both to the center channel output. Push this back into place. And I got my laptop set up over here with some music that I can actually play on this channel without getting a copyright strike. So we are gonna test this in 3, 2, 1. Okay. Oh, I don't know. Oh, it's not coming out of the speaker. Okay, hold on one second. This could still be a little bit of a receiver issue and not a speaker issue. No. Pretty Caroline, oh, 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 stone cold stunner. She was a winner, started working at the dawn. Now they're working and they sound great. Quick word of warning, if you're thinking about attempting a project like this at home, then just be aware that it is going to turn you into a little bit of an audio snob. I used to be the type of person who was perfectly happy listening to the free pair of headphones that you got on the plane. These days, not so much. I definitely notice a lot more when it comes to audio quality than I ever did in the past. So I guess the moral of the story is you shouldn't build your own speakers. They're time consuming to make, they're expensive, and they turn you into an audio snob. That is, unless, like I said earlier, you really happen to enjoy building things the way I do. I think these speakers look great, and I had a great time making them. So once you have your front and center channels all situated, the next thing I would recommend is a good set of rears. But I've got a little bit of a problem. You see, these speakers actually predate my career here on YouTube, so I don't have any footage of their construction. What I do have, however, is plenty of footage of the construction of these. These are Dolby Atmos height speakers, and the way they work is actually really cool. They bounce sound waves off of your ceiling in order to simulate the effect of sounds happening above you. But I'm gonna let you guys in on a little secret. The only difference between these speakers and my rear channels is some slight physical modifications to better focus the sound waves. So if you strip all that out, you have basically the same speakers. So I'm gonna show you how I made these, and I think if you watch with a critical eye, you can very easily see how I made these speakers. So the very first thing that I want to do on this project is build the speaker cabinets, and while we do that, I want to do one of my favorite things, violating the principles of good speaker design. Just like in my center channel project, I'm going to be building these speakers using solid hardwood. But this time around, I've got a trick up my sleeve that I think will help compensate for that non-uniform density. And that same trick should also help to compensate for another issue. I made the exterior walls of these shells really thin. You see, I wanted to make these speakers as small as possible, but I also needed a very specific interior volume in order for the drivers to function optimally. So the easiest way to do that was to just shrink the thickness of the exterior walls. However, this introduces a new problem. It's going to make the cabinets a lot more resonant, which is also not good for sound quality. So hopefully my plan works, but I'm getting a bit ahead of myself. For now, the last step was just a quick panel glue up to create a single large sheet of wood. Alrighty, while we wait for those panels to finish gluing up, we are going to cut the front baffles behind me on the CNC. We're gonna cut them out of MDF, but not because of its acoustical properties or anything like that, just because it's cheap and it'll be easy to paint afterwards. Now, obviously not everybody is gonna have a CNC at home, but don't worry, there are other ways to make these baffles. The first would be to just use a hole saw and then a trim router to cut out these recessed areas, or you could be really lazy and just order them online. The speakers I'm building are gonna be a modified version of the very popular Overnight Sensations, and there are a ton of retailers out there who sell kits to make them that include pre-cut cabinets. In fact, these kits are a great way for anybody to get started in the world of DIY audio and build out a 5.1 or 7.1 surround sound system. The rear baffles lacked any sort of cutout, so to save time, I just cut them on the table saw and then laid them all out so that I could give my pieces a quick coat of paint. I chose dark gray because I wanted to match my existing speakers, but obviously you can do whatever you want here. Just make sure you seal up all of the exposed MDF in order to keep it from absorbing moisture over time. With our panels now dry, let's talk about how we're gonna put them together. My plan here was to fold them into boxes. So the first thing I did was mark out where I needed to make all of my cuts. There's very little margin for error here, so I triple checked everything before cutting my miters. With my sheets now separated into panels, I set up over on the table saw to cut a series of rabbets and dados for our front and rear baffles. The easiest way to cut these channels would be to use a dado stack, but I don't have one of those. So I opted for the next best thing and cut them out one blade width at a time. Pro tip, by the way, when you're making a bunch of repeated identical cuts like this, plan it out so that you're adjusting your fence as little as possible. That'll keep your measurements consistent between pieces and make assembly later on a lot easier. As you can see, the front baffle slotted nicely into position, and as a final detail, I cut a small chamfer on the leading edge of each piece. Normally, this type of forward projection would be bad design, but it's gonna be important later. Now it's time for my favorite trick when it comes to making speaker cabinets. Lay out all your pieces edge to edge and then start taping their seams together. If you do it right, you should be able to fold them into their final shape and have everything lined up nicely. If not, adjust your tape and then just try again. When you do finally get it, apply some glue, slot your front baffles into position, fold it all together again, and then apply some clamps until the glue dries. You might be wondering why I didn't also install the rear baffles at the same time, and that's because we've still got quite a bit of work to do inside the cabinets. So let's talk about the crossovers. You might be thinking that for Dolby Atmos height channels, the circuitry inside these speakers would need to be pretty complex. But you'd actually be wrong. All of the crazy positional wizardry happens upstream in your AV receiver, and we'll talk about that more later. But because these crossovers are downstream of that, their only job is to do what all the other crossovers have done and sort high frequency sounds to the tweeters and low frequency sounds to the woofers. The only big change here is that I'm now using a perforated board that helps to keep all the things clean and organized looking. These are a great addition to any speaker build, and I'll make sure to include some links to them along with all the other tools and products I've used throughout this project in the video description. The last step was taking the crossovers and screwing them to the rear baffles so that they'll be easy to install a little bit later. Now that we are done with the electronics, we have our speaker cabinets here and they are now dry. So I think what we had to do is sand them and finish them, but that's kind of boring. So we're not gonna spend much time on this step. I'm just gonna do it quick. To keep things brief, I sanded everything down to 220 grit and then rolled on a coat of the same polyurethane finish that I used on all of my other speakers so that everything stays nice and consistent. Though, let's talk for a second about the consistency of hardwood. All right, look at these. These are looking really good. And this is actually really dark walnut, which is kind of one of the things that I like so much about walnut is you never really know what you're gonna get until you start milling it down. Now that we've got these all finished, counterintuitively, we have to cut into them a little bit. Normally, you'd put the holes for an input plate and a breather port on the rear baffles, but with these speakers, because of their orientation, that's not really gonna work. So I picked a side that will eventually face away from me and cut them there instead. The breather ports were easy, but because the input plates are square, I had to cut these holes using an oscillating multi-tool. This is my go-to choice anytime I need to cut straight down into a flat surface, and it's a really handy tool to have in the shop. A quick test fit made sure my holes were big enough, and then we were ready to move on. So now I would like to fix a problem that I created earlier in the build. Because I made the wood of these cabinets so thin, they're quite resonant. They've got a good drummy sound to them, which, as you might imagine, is not great in a set of speakers. So in order to fix that, I would like to borrow a product from the automotive world. Anyone who's ever installed a subwoofer in a car knows all about this stuff, Dynamatic. or rather its generic cousin, which you can order off of Amazon for pennies on the dollar. This is a foil-backed butyl rubber, which you can stick to just about any surface. And the beauty of it is that it absorbs vibration and kills resonance. So I got a bunch of small sheets that were perfectly sized for the inside of our cabinets and then stuck them in place. Okay, now that we got the first one done, it's time for a super scientific test. Here's that one and that one. As you can hear, it still knocks, but this one is quite a bit sharper and more resonant. So yeah, I think that actually worked quite well. Oh, and as an added bonus, it makes the inside of the speaker look really cool, which is obviously the most important thing when you're building speakers. So, as you can see, these sheets drastically reduce the resonance of our cabinet, which should more than compensate for our thin hardwood shells and should make for much cleaner and crisper positional audio. Alrighty, now we get to do my favorite part of any speaker build. We get to put all the components together inside the cabinet. Step number one was creating what looks like a repairability nightmare. I installed the rear baffle using a flexible adhesive that will create a permanent airtight seal so that air can only go in and out through the breather port. This isn't an issue though, because like I said in the tower speaker build, a principle of good speaker design is that all of your internal components should be sized so that they can fit through the largest driver hole. So if I ever need to get in there to do anything, I can always do it through the woofer cutout. Next, I soldered two leads coming off the crossover back to the input plate. Some people will use crimped on friction fittings for this, but I much prefer to use solder as it offers a more permanent and secure connection. And similarly, I did the same thing for the woofers, which are Hi-Fi B4Ns, and the tweeters, which are from Dayton Audio. I've got a lot of experience with these drivers as I've used them in many of my other speaker projects. Not only do they sound great, but they also look great with their metallic cones. The only downside to them is that most people just assume they're Klipsch drivers when they see them in person. Before we install these last two panels here, I want to take a second and stuff these speakers. This is polyfill, and it's essentially the same stuff you'd find in a cheap pillow or a stuffed animal. This stuff's going to go inside the speaker, and it's going to help to cut down on resonance and make the speaker sound a little bit better. Smells like nothing. If you're doing this at home, you might be tempted to pack as much polyfill as you can into a set of speakers, but there is a balance to be struck here. I'd suggest putting in just enough to loosely fill the cabinet. Err on the side of underfilling rather than overfilling. So let's talk about the projection at the front of these speakers, because conventionally speaking, this is bad speaker design. As the sound waves come off your front driver, they're going to reflect off of these edges, and you're going to end up with a very muddy sound signature, which is not what you want. But these are not conventional speakers. The goal of these speakers is going to be to shoot sound waves up to the ceiling and then bounce them down. So in order to help direct those sound waves, we are actually going to line these front projection with some acoustic panels. These will absorb sound waves coming off the drivers at oblique angles, which should, in theory anyways, focus our sound waves into more directional beams. That way, you're only hearing them as they're reflected off the ceiling. Now, thankfully for me, these panels were really easy to cut, so I was able to chop them up into smaller pieces and then just glue them in place. Ooh, would you look at that? Our speakers are now done. So I think the next thing that we have to do is take them home, hook them up to my AV receiver, and see if they actually work as height speakers. Oh, and as I'm tilting the speaker like this right now, I'm just realizing we still have to make a custom mounting solution that will hold the speakers like this, because I can't just, kind of like balance them like that. That's not gonna work. Unfortunately, anyone who saw my coffee table project knows that this is going to be a big pain in the ass. My AV receiver, which is going to be the brains of this operation, is hidden in a compartment below my coffee table. This magical black box is responsible for figuring out what speakers need to play which sounds in order to create the 3D positional effect. So, in order to install these new speakers, I had to run 2 lines from it under my carpet and then up the backside of my original tower speakers. It did take a while to set this all up, but it was well worth it to keep everything looking nice and clean. Like I said before, we have a very obvious problem. Our speakers are pointed directly up at the ceiling, and given that our seating area is over there, it's probably not going to sound the best. So what I want to do is come up with a solution to get these speakers to sit a little bit more like that. And in order to do that, I think we better go use the 3D printer. So this is what I came up with, and it's not dissimilar from a GoPro mount if you've ever seen one of those. Basically, you have 2 halves with some fingers on them, and the fingers interlock like that. And then if you look over here at this finished one, what I've done is I've threaded a bolt through there. There's a couple friction washers between the fingers, and then on the other side there's a nut. So as you tighten down on this bolt, it basically locks the fingers in whatever position you want. And the cool thing about this is that you can adjust it to basically any angle and a multitude of heights. So it should give us a ton of flexibility for positioning our speakers. Downstairs, a little bit of double-sided tape did a surprisingly good job of holding my new brackets in place, and then it was time to do some calibrations. Over the next couple of hours, I did two things. The first was testing out various angles on my brackets and seeing what gave the most convincing overhead effect from the speakers. And then the other one was running the room correction process on my AV receiver. This involves placing a mic at various seating positions around the room and playing a test sound out of each speaker individually. The receiver then takes that data and uses it to work some EQ magic to compensate for any asymmetries in the room and any suboptimal placements of your speakers. All right, so I guess the thing that we have to do now is test to see if they work. And it was actually surprisingly hard to find content that I knew had Dolby Atmos and height channels in it as well, but I hear Dune on Netflix does it pretty well. So I'm gonna watch this for a minute and then give you guys my impressions. Pretty much right away, I was confronted with something that I didn't really expect going into this project. There's just not that many sounds that happen above your head as the viewer in a movie. What I noticed more than anything was the change in height of objects on the screen. For instance, when these helicopters move from the bottom right to the top left corner, you could definitely hear them changing height within that plane, but they never really sounded like they were right above my head, which makes sense given the context of that scene. Overall, despite my initial misunderstanding, I was still really impressed with this technology, but that was only the start of my testing. One thing that I wanted to test is the PlayStation 5 just got a software update, and now the PlayStation 5 supports Dolby Atmos. So let's give that a shot and see if that's any different. You know what? What I found here was equally surprising. At first, I thought that Dolby Atmos would only be supported by the latest games because it's such new technology on the PS5. But what I found is that it actually works flawlessly even on older titles. I guess somehow they found a way to port the old 3D positional audio over into Atmos. Okay. That might just be a game changer, especially in an older title like this. This is like a tech demo from the launch of the PS5. I didn't actually think it was working at first, but then as soon as I went into an area where there was stuff happening above my head, you can immediately sense that the sounds are coming from a higher plane. Again, it's like the movie. It doesn't sound like it's happening directly above your head, but you do really get the sense that the sound is coming from a higher point in 3D space. Bottom line, I think this is really impressive, and it's going to add a whole new dimension to my catalog of games. So that is how you build your own DIY Dolby Atmos height speakers. And while they don't work exactly the way that I initially thought they would, they do work surprisingly well, maybe even better than store-bought ones. So that is how I built my entire home theater, with one glaring omission: the subwoofer. Now, looking at this thing, you might think that, yeah, Zach probably built the subwoofer. But you'd only be half right. What I actually did was take a clip subwoofer and reskin it to match the rest of my speakers. So it's literally just an off-the-shelf subwoofer that's wrapped in a thin layer of walnut. But again, it predates my career here on YouTube. So as we wrap up this video, I've got a question for you guys. Would you like to see me build a sub from the ground up? Because I've actually got an idea for one that I would love to build. So let me know down in the comments, and I will see you guys in the next video. Peace.